All right, hello everyone. It's me again, Michael. Let's go ahead and take a look at a question from sprint number 19, which I think I actually read this question. Reads, Jolie is wandering through Chickenquackland when she finds a magical pie machine. To make a pie, she chooses exactly one of the four available pie crusts, at least two of the five fillings, and at least four of the six toppings. However, if Jolie chooses exactly three fillings and five toppings, then the pie machine explodes and no pie is made. Given that the machine only explodes in this case, how many different pies can Jolie make with the machine? Now, this problem looks at combinatorics, which is essentially like how many ways we can order or choose or group some certain set of items. So we have to satisfy all of the conditions for pie crusts, fillings, and toppings. So for pie crusts, we can only pick exactly one pie crust, right? So I'll abbreviate pie crust with PC. There's only one way to do that. We have to choose one of the four, so that's four choose one. So we have four ways to choose pie crusts. Now, if we look at fillings, right, we have to choose at least two of the five fillings, which means we can choose two or more of the five fillings. So this becomes 5 choose 2 plus 5 choose 3 plus 5 choose 4 plus 5 choose 5 ways to choose fillings. And this is equal to 10 plus 10 plus 5 plus 1, so that we have 26 ways to choose the fillings. Jolie has 26 ways to choose fillings. And then we need at least 4 of the 6 toppings. So again, toppings... that is indeed not in equals. For toppings, we can choose 4 or more. So that is going to be 6 choose 4 plus 6 choose 5 plus 6 choose 6, which is going to equal 15 plus 6 plus 1 equals I believe 22. So that means that Jolie has 22 ways to choose the toppings. Now, if we multiply all of these together, right, we have 4 ways to choose the pie crust, 26 ways to choose the fillings, and then 22 ways to choose the toppings. That gives us a total of 2,288 possible pies. And we might think that's our answer, but it's not quite our answer. And the reason for that is because we have this other condition here. There's a bug in the pie machine. If Jolie chooses exactly 3 fillings and 5 toppings, then the pie machine explodes and we don't get a pie. So we have to figure out how many ways there are for that to happen. So the number of ways there are for the pie machine to explode and we don't get a pie is there's no restriction on pie crust, right? So there's still 4 ways to choose the pie crusts, because the pie crusts don't affect the explosion of the pie machine. But then for fillings, we have to choose exactly 3 of the 5 fillings. So 5 choose 3 is equal to 10. And for toppings, we need to choose exactly 5 of the 6 toppings. So that's 6 choose 5, which is equal to 6. So that means that there are a total of 4 times 10 times 6, or 240 cases in which if Jolie puts something in, the pie machine will explode, and sadly, she will not get a pie. So that means that the number of different pies that Jolie can make with the machine is equal to the number of pies with no restrictions other than the numbers of fillings, toppings, and pie crusts, minus the number of cases in which we can have an explosion, which gives us a total of 2,048 different pies with no explosion that Jolie can make with the machine. So that is our answer.
This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.